Today I'm going to show you how to multiply two binomials. I'm going to give you 3 different methods, and at the end of this, hopefully you'll pick one that you like the best and you can use it to try some problems on your own. Hopefully you'll see that this is not two binomials. This is a monomial times a binomial. Very simple. You are probably thinking distributive property, and you're correct, where you just multiply the guy on the outside times both of the guys on the inside. So x times x is x squared, and x times -8 is -8x. And there's your answer. Well, we're going to do somewhat of the same thing when we get to the two binomials. I'm going to use distributive property, but because I have two terms inside my first parentheses, I'm going to do the distributive property twice. Let me show you what I'm talking about. I'm going to do this one times both of these. And then after that, I'm going to do the second term times both of the terms in the other binomial. So let's start this off. When I did the first one, here, let me go ahead and erase these for a moment. All right. I'm going to do x times x and x times -8. So x times x is x squared. X times -8 is -8x. Then what I'm going to do is I'm going to take the -5 here, and I'm going to multiply it times each of the terms. So -5 times x is -5x, and -5 times -8 is +40. Now the last thing I need to do is I need to see if there's any like terms I need to put together. And sure enough, right here in the middle, there's like terms. So x squared, a -8x, and a -5x is a -13x, and then plus the 40. Almost always, you're going to get a trinomial when you multiply two binomials. Now, that doesn't happen all the time, but most of the time, you're going to get a trinomial. Go ahead and try it on your own, and then come back. All right, here we go. Distribute this to this and this to that one. So 2x times 3x. Remember, multiply your numbers and add your exponents. So 2 times 3 is 6. And then this is literally x to the power of 1. And this is x to the power of 1. So that would end up being x to the power of 2. And then 2x times -5. -5 times 2 is -10. And then bring that x along for the ride. And now I'm going to go ahead and do the bottom part. 1 times 3x, well, 1 times anything is itself, so 3x. And then 1 times -5 would be -5. All right. Find that I have these like terms. So when I put it together, I'm going to get a 6x squared. Looks like a -7x minus 5. There you go. Method number 2. Actually, method number 2 is the same as the distributive property, but without using the arrows. Here's what I'm talking about. It's called FOIL, and FOIL stands for first, outside, inside, last. What? Well, here we go. First. The first is just multiply the first term in each of the binomials. So 4x times x. So that's going to give us a 4x squared. Then, let me go ahead and erase that. The O stands for outside or outsides. It doesn't matter. And that's going to tell us that the two numbers that are on the outside of this problem, the 4x and the 8, we're going to multiply those next. So we're going to do 4x times 8 is 32x. Again, that's the same thing as when we just did our arrow like that. All right. The I stands for inside. Can you figure out which ones are the insides? Well, that's these two right here, the -5 and the x. And so that's -5 times x is -5x. And then finally, the L stands for the last, which again just means the last number in each binomial times each other. So in this case, it's the -5 times the 8, which is -40. Minus 40. And just like before, you're going to have, most of the time, your two middle terms are going to be like terms, and you put them together. So I have 4x squared, and that looks like that's going to be a 27x. minus 40. So again, FOIL, first, outside, inside, last, is just an acronym so that you could remember what to multiply without having to draw the arrows. All right, I would suggest that you use FOIL and do this. And pause the video, use FOIL, see what you get. Try it out. All right, hopefully you did that, and now you're back. I'm going to teach you another method called the box method. And I'm literally going to just draw a box. And since I have 2 terms in each of those, I'm going to make this box a 2 by 2, just like this. And I'll take the top term and put it here, x, and then keep that minus sign as like a -3, and then 2x, and then a positive 9. Next, I'm going to treat this just like a multiplication table. In this first box, it's going to be whatever 2x times x is. And then the next box will be whatever 2x times 3 equals, and so on and so forth, just like a multiplication table. All right, let's get rid of that. And so here we go. 2x times x is 2x squared. And then right next to it, 2x times -3 is -6x. And then down below, we're going to do the x times the 9, so 9x. And then finally, the 9 times the -3, which is -27. Almost always, you're going to have a diagonal that has like terms. And there we go. The x's are right there. And so I'm going to put it all together. 2x squared. Then 9x minus 6x is 3x. And you have the -27. All right, there you go. That's how you do it. This might be a good time to pause the video and try it on your own. All right, here we go. I'm going to make a 2 by 2 box. Now, why 2 by 2? Well, because I have 2 by 2 polynomials. I have a binomial and a binomial. If one of these was a trinomial, then I'd have a 2 by 3. All right, 10x plus 3. And then I have here a 3x plus 4. It really does not matter which one goes on top and which one goes to the side. It doesn't at all. All right, now 3 times 10 is 30, and then x times x is x squared. And then right beside that, I have a 3x times 3. So 3 times 3 is 9, and then with the x. Down below, 10 times 4 is 40, and then the x. And then finally, 4 times 3 is 12. All right, and these are my like terms right here. So I'm going to have 30x squared plus 49x plus 12. All right, is that what you got when you did it on your own? Hope so. All right, go have some fun doing problems like these.